Greetings, Saints. We're going to get started with lesson 10.1. I'm going to kind of try to consolidate this instruction from what I had done previously. What we have here is we're going to start to detail some of these relationships we can have with lines and circles. So I'm going to have some different relationship names. What they're called is one thing. It's important, I believe, but I think the big thing is that you have to be able to identify the relationship that you have, and in order to work with it, uh, as it pertains to problem solving. So it's this, for example, we're gonna have a circle here, and you're gonna need your compass to create some circles over and over and over again. All right. So I've got a line. I gotta be really careful here as I'm drawing lines today. I'm gonna do my best. Oh man, I'm trying to use a straight edge here to clean this up a little bit. There we go. All right. So I got a line. Oh, geez. Let's see here if I can undo that. There we go. Goodness gracious, guys. It's kind of tricky here with tools that I have at my disposal, but we'll see if I can make work. Okay, here we go. So I got a line that has a tangent point to this circle. All right. And this point P is this point of tangency. This is line AB. And then there's this secant line PC. Okay. It's a chord right through the circle. And then I'm going to just additionally have this other point D so that I can identify both a minor arc and a major arc. Okay. So what we refer to this as is this is the relationship secant tangent. And this is secant tangent where the intersection is on the circle right here at P. Okay. Where the intersection of the secant tangent on the circle. Because we have several different possibilities here, and we're going to detail all of them. And there's a formula on what to use. So as long as we identify the correct relationship, we can employ a formula. And gentlemen, I'm going to promise you here on this next chapter test, you will actually get a note card because it's going to be very formulaic. All right. So here's what we do. To find the measure of angle BPC. Okay. So this angle right here, that angle is going to be equal to 1/2 of this intercepting arc PC. All right. And then that major arc APC is equal to 1/2 the measure of PDC, this intercepting arc. Okay. Pretty straightforward. It's just half. All right. So let's do an example problem. Here we go. If we have the measure of arc PC is 100, then the measure of angle APC is what? All right. And how do we do this? So it's saying that PC, the arc, is 100. Now it wants this angle. If this is 100, right? The arc is equal to 1/2 of that arc is going to be the angle. So then that means BPC, right, is going to be 1/2 of 100, which will be 50. Okay. And this guy's 50. The measure of APC, it's going to be supplementary, right? Because this is going to be a linear pair. So this guy would have to be 130 degrees. Okay. All right. Next. Let's go ahead and make a circle. And I'm going to make a couple of secant lines, but I am not going to put the intersection inside of the circle. I'm sorry, I will put it inside the circle, but I'm not going to put it at the center. Okay? So I have two secants. This is 1, this is angle 2, and this is going to be line AB, and then line CD is my other secant. And the question is, what are the angle measures? Now, what we've done so far, right, is like if we had a central angle, like if we had this angle at the center, it would be at this corresponding. Oh goodness gracious, guys, I'm really struggling here. I've had a center point, right, and I would just make it would correspond to whatever these arcs open up to. But that's not how this is going to work. So I'm going to show you guys a quick proof, rather than just the the random old trust me bro sort of thing about this, right? So let's create an auxiliary arc real quick, okay, or auxiliary chord right here to make this triangle now, which will be angles 3 and 4. Okay, so if you guys recall, take a look here. I have here this exterior angle theorem, right? Where if I have angles 3 and 4 and I have angle 1, if you guys recall, the measure of angle 1 in the exterior angle theorem was going to be equal to the sum of angles 3 and 4. All right, so that's cool. And since the measure of angle 3, you guys also know now, is going to be equal to 1/2 of this arc right here. Because it's that corresponding minor arc to this inscribed angle, because that's right, because that angle 3 has its vertex on the circle. So if we're going to do the measure of angle 4, if I had my diagram down a little bit better, that's going to be 1/2 of this arc right over here, AC. So we can do some substitution. Excuse me. That the measure of angle 1 is really equal to 1/2 of arc BD plus 1/2 of arc AC, which we could factor then to figure out what angle 1 is. And it's going to be 1/2 of the sum of arc BD and arc AC. Okay, so that's effectively my formula right here. Is that when I have this, for this angle 1, it's going to be equal to 1/2 of the sum of this and this. And then correspondingly, angle 2 is going to be 1/2 of the sum of this and this. Now, then, of course, the question would be, well, what about this angle right here? Well, of course, it's a vertical angle with 1, and it would be the same thing, right? So here are my formulas for angles 1 and 2, that the measure of angle 1, as we just detailed, is equal to 1/2. The measure of AC and BD, or BD and AC is how we just did it, right? And the measure of angle 2 is equal to 1/2 of BC and AD. All right. So let's do another example. Here we go. Auto shape action. Just take the auto shape guy off because he causes me some problems sometimes, and I'm just trying to do things like write letters. So I'm going to do another secant here. All right. And I have this guy is 94 degrees. All right. And this arc is X degrees. And then this arc is 80 degrees. And we're going to solve for X. All right. So in order to do that, well, what do I need? Well, I need to know what this is. So I'm going to actually call this guy Y right here. Okay. And that Y is going to be a linear pair with 94, right? So this guy has to be equal to 86. Okay. Some of you guys are going to come to class and ask me about that, but I just pointed out it's a linear pair. So that's how I can kind of tell if you're not, taking your notes and you're just kind of writing this down. Y is equal to 1/2, right? This angle equal to 1/2 of this arc and this arc, two sums. Okay, so 1/2 of 80 plus x. But we already know what y is, right? Y is 86, so that's 1/2 of 80 plus x. And now this is just an algebra problem, right? Multiply both sides by 2. Okay, get on my calculator. Oops. Okay. Is 172 is equal to 80 plus x. Subtract 80 from both sides. And x is going to be, oops, not 90, but 92. Okay, right? 172 minus 80. All right. Next, I'm going to give you guys some details here. And I'm going to give you these formulas, but what the important thing is I'm going to detail the same logic each time, because the logic of how the formula is assembled doesn't change. So now we've had these, we've had the secant tangent with the intersection on the circle. We've had secant in the circle. We can't have tangent in the circle, right? Tangent happens outside, and we already know the result with those, with that thing. And we'll talk about that in a moment. Let's draw 3 circles side by side. Circle, circle, circle. Okay? These allergies are kind of going. It's that time of year, guys, so I'm sorry for all the sniffling. Move these over a little bit. Right. A little bit less of a painful situation for you guys. So first one I'm going to draw here is I'm going to draw a point exterior to all 3 of these circles. Okay, and now from that point, that's going to be my point of intersection, and it happens outside the circle. So 2 ways we can do it. We can draw one with a tangent line, okay, right there, and then one with a secant line, and this guy's actually called secant tangent. Okay, I have another one where I have my point exterior, and I'm going to draw a secant and a secant, literally called secant. It's fun to say. And then the next one, actually, as I was discussing, there's the other possibility, which we'd have, oh gosh, this is the tough, tricky one to draw here. You guys probably are guessing it right now what it's going to be, but it's going to be tangent. Man, missed. Tangent, okay? All right. So we have A, B, C, what tangency is C, and D. I have point A, B, C, and then D, E. And then I have A on the outside, and I have my point of tangency, and my point of tangency, B and C. But I'm going to give myself another point on this arc, just so I can detail the difference between the minor and the major arc, right? Minor arc being closer to that point of intersection outside. So gentlemen, here is how the logic works. We're going to find the measure of angle A each time, okay? And the measure of angle A, the logic is consistent, okay? It is the following. I know you guys get a formula card, but I want you to always think of it as this. It's going to be always 1/2, just like it was prior, right? Just like it was with, well, back at the beginning, secant tangent was 1/2, right? Even secant in the circle was 1/2. So these secant tangent, and tangent, it's always going to be 1/2, 1/2, 1/2. And then now it's going to be the difference of 2 arcs, and it has to do the arc outside and then the arc inside. So the furthest to the closest. So it's going to be the difference of the measure of arc DC minus the measure of arc BC. Furthest to closest. for angle A. Here on secant secant, it's the measure. It's the outside guy, the furthest, DE, to the closer one, BC. Same logic here for tangent tangent. The far one is that major arc BDC subtracted by the closer minor arc, which is BC. All right, so let's do one of these problems, okay? See how it goes. You guys can see if you can identify which relationship it is. Right, here we go. Still working on blue, that's okay. Now I'm not going to even name these, right? Some people are like, oh no, I don't, there's no, nothing for me to follow here. Oh, you know, let's do it. Let's actually give you some letters just for fun. Okay, reorient this. A, B, C, D, and E. And the only thing given is that this arc is 100 degrees. This arc is X degrees. And this angle right here, angle A, is 35 degrees. And we are going to solve for X. So, how do we do that? Well, remember, A, the arc, oh man, I got my little auto circle thing on there. Okay, here we go. A, the angle, is going to be equal to the outer, 1/2 of the outer, minus the inner. So, what is this? Well, remember, this is actually secant secant, okay? But it's done the same way, regardless of it being secant tangent, secant secant, or tangent tangent. It's still going to be the angle equal to 1/2 of the outer minus the inner arc, okay? And then now this is algebraic, and this is just 70 is equal to 100 minus x minus 100 minus 100. I have negative 30 is equal to negative x. So 30 is x. I'm done. All right. 2 more examples for you guys. And it's going to be involving the same angle kind of relationship. And it's going to be 2 ways to look at tangent tangent for us. Okay. Here we go. We're going to take circle R. All right. Circle R. And I've got this point S, which is exterior. And this is a tangent line. You guys are going to have to use your imaginations for me. I know. I'm just doing the most awesome job drawing for you guys, but I'll get better. My angle S is exterior. Okay. P, I'm sorry, I call this circle R. P is one of the points of tangency, and Q is the other point at home. Oh, gosh, I gotta get rid of the auto thing. It's gonna drive me crazy, guys. I'm trying to write letters like Q and then making it into a circle. Okay. So here's what we're given. Okay, and we're gonna discover something kind of cool right here. We gotta find X. Okay, solve for X. And the only thing we're given here is this. This central angle of 124 degrees. All right. So this is given that we have circle R. Solve for X. Now watch what happens, fellas. We're going to do the following. Okay. If this is 124, because that's going to be the same as the central angle, that's nice. Okay. So this is going to be 124, meaning how do we get the major arc? Well, we're going to take 360 and subtract 124, right? And that's going to give us 236. So that's the outer arc here, the major arc. And then this is going to be angle S, right? Which is going to be equal to 1/2 of the outer minus the inner, all right? And angle S is actually the variable X. And then we just plug and play, okay? 1 half of 236 minus 124, which is 112. And half of that is equal to 56 degrees. Now, take a look at this. If I have 56 degrees here, that means this relationship is that this angle right here, this exterior angle to the central angle, right, is going to be supplementary. Okay? And that's not a coincidence. There's a proof that we can do. I'm not gonna. I'd like to say sometimes the juice isn't worth the squeeze. Okay. It's one of the ways for us to think about this. I could do the outer minus the inner, but let's do this a little bit differently this time. Okay. Let's actually just employ that, and we're gonna try to do a lot with a little. You guys are gonna see how these are gonna go when we get to this chapter test. I'm gonna give you guys very, very little to work with, and you just have to be able to identify the right relationship and go from there. Okay, and if we do that, problem should be actually pretty fast. So we have tangent, tangent again. All right, here in our tangent, tangent, I'm being given that I want to solve for, given this, 42 degrees. All right. And I have A, C, B in my circle O. And this is D that's out here. Okay. And if I have a 42-degree angle out there, the question then becomes, what are those angle measurements? Okay. For example, what is the measure of arc AB and the measure of arc ACB, the major arc, right? Well, thinking about this, remember the relationship here between this and this is these guys are supplementary. So I can just take 180 and subtract 42 to get myself 138. All right, so it means this is 138, meaning that this is 138. So then I could just take 360 and subtract 138, right, to get 222. And that's going to be this arc out here, and that's going to be 222, okay? And then here's the question. Let's solve for the following, okay? If I were asked to solve for this angle X, okay? X is going to be really simple to come up with, right? I don't need to actually solve for too much in terms of difference of arcs and so on and so forth, right? Where I wouldn't have to say that 42, right, would be equal to 1/2 of, you know, 222 minus whatever, you know, that arc is, which is AB. And we already know that AB is going to be equal to, or half of AB, right, is going to be equal to angle C because that's an inscribed angle, right? But I don't even have to go through all of this. This is not something that I don't necessarily even need to deal with because look at this. I have an inscribed angle right here too, right? Angle C is inscribed to this, which I already figured out the supplement. So 1/2 of 138, which I already know, 69 degrees, okay? And there you go. X is equal to 69 degrees. And that's it, gentlemen. Good luck If you have questions, please come and see me.